Hello, welcome to Lessons with Philip. And our topic today is trigonometrical ratio on angle 30 degree, 45 degree, and 60 degree. Why is this topic important? Sometimes examiner or an OBJ questions give answers in short format. So if your examiner asks you to give your final answer in short format, this is very important. All right. Now let's start with angle 45 degree. Now, trigonometrical ratio of angle 45 degree is derived from a triangle known as right-angled isosceles triangle. A right-angled isosceles triangle. If I have a right angle on the board, this is a right angle. A right-angled isosceles triangle, right-angled isosceles triangle. That means this triangle will have two things in common. It has two properties. It is a right angle triangle and it has an isosceles sides. That shows that two of its sides are equal. So automatically, this place will be 45 degree and this other side too will be 45 degree. All right? Are we following? So if I call this side to be 1 unit, so this side will also be 1 because they are equal. They are isosceles sides. So this place will be sub 2. How do I get sub 2? If I use my Pythagoras theorem, don't forget, if I'm considering this angle, which is 45, this will be my opposite, this will be my adjacent. So don't forget, Pythagoras theorem says hypotenuse line squared equals to opposite line squared plus adjacent line squared. Please carefully follow me. All right, I'm trying to prove trigonometrical ratios. All right, now the hypotenuse is what I don't know. If I call this place x, for example, if I call this place x, so x squared equals to my opposite, which is this place, is 1 squared, and my adjacent is also 1 squared. Automatically, my x squared equals to 1 squared is what? 1, and 1 squared is also 1. So my x squared equals to 2. Automatically, my x equals to sod 2. That is why I get this place to be sod 2. Okay? Now, if I consider this triangle that I have on the board, now my sine 45, this is where I'm going. My sine 45 degree, don't forget, sine, trigonometrical ratio, this with so, ka, so, all right? All right, sine equals to opposite of hypotenuse. What is my opposite? This is my opposite. This is my adjacent. And this is my hypotenuse. So my opposite is 1. My hypotenuse is sod 2. All right. Now, my cos 45 degree will be equals to, what is cos? Adjacent over hypotenuse. My adjacent is 1 and my hypotenuse is sod 2. All right. What is my tan 45, which is 1? My tan 45 equals to, tan is opposite over adjacent. Opposite is what? 1. And adjacent is 1, which is equals to 1. All right. That is how we derive these trigonometrical ratios. These trigonometrical ratios for sine 45, cos 45, and tan 45. In our coming videos, we'll begin to use this. All right. So you need to know it. So if you forget, just draw this out. You derive it straight. All right. Let's go to angle 30 degree and 60 degree. Now, trigonometrical ratio for angle 60 degree and 30 degree is derived from a triangle known as equilateral triangle. All right, it's derived from what we call equilateral triangle. All right, somebody said I should write it. Equilateral triangle, from the word equal, equilateral triangle, from the word equal. So that shows that the three sides are equal. Somebody is saying This is a triangle that doesn't have right angle. Then how do I get my 90 degree? Don't forget what we did in one of our figures. Now, if I bisect this triangle into two, if I bisect this triangle into two, I have this. In an equilateral triangle, this side is 60 degree, this side is 60 degree, and this entire side is 60 degree. All right? Because I have bisect this triangle into two, it changes 60 degree. This side will be 30, this side will be 30. Automatically, I have this. I have this triangle on the board. Okay, this is, don't forget, anytime when you bisect a line, you have a right angle. Automatically, this is 60 degree and this will be 30 degree. Okay, so I have my 60 degree, I have my 30 degree, so I can derive my trigonometric ratio for 30 degree and 60 degree. Do you get that? Now, in this case, if I call this place 2, I want to use 2 because I'm dividing this line so that I will have a value that can be divided that will give me a direct figure. So I will have called this one 1, but if I call this place 1, this place will be 1, this place will be 1. So automatically this will be half, and this place will be half, which is 0.5. I want to have a straightforward value. So I have this place to be 2. What will this place be? It will be 2. So this place to this place will also be 2. So automatically, because I have divided this line into 2, this place will be 1. So this place will be 2. Okay, it's still 2. So this place is unknown. It is this line which is unknown. So if I want to find this, I can find it using Pythagoras theorem. All right? So if I want to use Pythagoras theorem, what will be my Pythagoras theorem? This is my hypotenuse. So this will be my opposite. And this will be my adjacent. So Pythagoras theorem says hypotenuse line squared equals to opposite line squared plus adjacent line squared. This is my Pythagoras theorem. All right? All right? So my hypotenuse is 2 squared equals to my opposite, which I don't know. Let me call it x, which is my x squared plus this place, which is 1. Don't forget, it is this place to this place, which it is half of these two, which is 1 squared. All right? So my 4 equals to x plus 1. So automatically my x equals to my x squared equals to 3. So my hex, let me write it here. So my x equals to sod 3. So this place, if I rewrite this diagram, so this triangle, we have to use triangle to be this. So we have this triangle to be this. So this place is now sod 3. This is 1. This is 2. And this is 60 degree. And this is 30 degree. Let me draw another triangle. All right? To display my 30 degrees. So this will be my 30 degree. This is my sod 3. This is my 2. And this is 1. All right? It's the same triangle, but I don't want to confuse you. All right? So from this triangle, if I want to go for my 30 degree, my 60 degree, should I start with 60 degree? So this place will be my opposite. This place will be my adjacent. And this place will be my hypotenuse, because it is a side that faces the right angle. Automatically, my sine 60 degree will be equals to, don't forget, from SOHCAHTOA, opposite of hypotenuse. My opposite in this place is what? So 3. My hypotenuse is what? 2. Right? So, whereby my cos 60 degree equals, cos is what? Adjacent over hypotenuse. My adjacent in this case is 1, and my hypotenuse is 2. All right? So my tan 60 degree equals to what? My tan is what? Opposite over adjacent. My opposite is sod 3 and my adjacent is 1. Automatically, my tan 45 is still the same thing as sod 3. All right? So with that, what will be, if I consider this will be my what? My opposite. This will be my adjacent, and this will be my hypotenuse. So my sine 30 degree will be equals to, sine is what? Opposite over hypotenuse. My opposite in this case is what? 1. My hypotenuse is what? 2. All right? So my cos 30 degree will be equals to, cos is what? Adjacent over hypotenuse. My adjacent in this diagram is what? Sod 3, and my hypotenuse is 2. All right? Now tan, which is the last one, tan 30 degree equals to, my tan is what? Opposite of adjacent. My opposite is 1, and my adjacent is sod 3. Automatically, this one is still equivalent to sod 3 over 3. Please take note, tan 30 degree equals to 1 over sod 3, which is equals to sod 3 over 3. Later in our class, later in our coming videos, we're going to deal with how we rationalize sod. We're going to deal with sod as a topic. Okay? Now, anytime when you see tan 30 degree, you can replace with sod 3. Anytime when you see sin 45, you can replace as 1 over sod 2. Anytime when you see tan 45, you can replace it as 1 as 1. All right? This aspect is very, very important, because when we go further into trigonometry, you just see us using 1 over 2 in place of cos 60. We can use all these values which I have displayed on the board. All right? This is how we are able to derive sin 45, cos 45, tan 45, cos 60, sin 60, tan 60, sin 30 degree, tan cos 30 degree, and tan 30 degree. In my coming video, we'll do more examples on the application of all these trigonometrical ratios. Thank you. See you in my coming videos. Bye.